Hello and welcome everyone to today's webinar, Securing Your Kubernetes Clusters, Part 2, how to proactively prevent attacks. I'm not sure if many of you have already been there yesterday. If you already have been there yesterday, then welcome back. My name is Chrissy. I'm really excited that so many are joining the session. And today our speaker, Hubert, will cover topics like encryption, image scanning, admission control, threat detection, and many other topics. In case you missed the first part of this like 2-session series, then you can check it out on YouTube. I will post the link in the chat so you can have, so you have access to that. Also, in case you need to drop out early of this webinar, no worries. This is recorded and you will get an email in the coming days with the recording. And in case you have questions, just type them into the Q&A section so we can either answer them straight away or then later in the Q&A section at the very end of this webinar. And with this, I'm happy to already hand over to our Kubernetes trainer, Hubert. Your stage.
Thanks a lot, Chrissy. Thank you for the welcome words. So also from my side, hi again. Part 2 of the Lines of Defense webinar. So dive directly into it. Maybe a few words what we did yesterday, a short reminder. We were talking about the architecture, how to install Kubernetes, and then we took a look at how kubelet authentication authorization can be configured, and this is already an important part of the security topic. Make sure your kubelets are safe. And for sure, the first part was firewalls. This is also a very important topic for sure. Then we took a look at identity theft. So you can, import the service account tokens are in there by default. So this is also something you have to take a look at. And then we started the topic encryption and started with encryption at usage. And Hakarius, the villain, still is trying to do evil stuff, but our hero, King Admin, doesn't care that much. Let's talk about encryption at rest. We will today we have to cover a lot of stuff again. And as Chrissy mentioned, please post any questions in the chat. I will try to answer your questions after the talk. So encryption at rest. Our polis, Kubopolis, has in the main city something which is called etcd, and etcd is the database which stores the whole state of Kubernetes. And now Hakarius wants to steal sensitive data from etcd. And yesterday we also have been talking about secrets, that secrets are not encrypted, they are only encoded. And it even gets worse in etcd. By default, they are in plain text. And we will change this in a few minutes. We are adding an encryption config, and with an encryption config, you can say, for example, like in this encryption config, I want to encode all secrets with this encryption key. Afterwards, you have to teach this encryption config to the API server. And this is what we are doing now live, and hopefully this works out. Everything's running, looks nice. Before we start into adding the encryption config to the API server, some stuff about etcd. In the static pod manifests directory, you see etcd also in there. And for being able to talk to the etcd database directly, you need some URLs and some certification authorities and some certificates. So this is the reason why I show you this static bot manifest, because all the information is in here. I made my life a little bit easier and stored all that stuff in some environment variables, so I can do stuff like etcd control. So I can, in general, talk to the etcd database already. Another thing which is maybe interesting here is where is the data stored? And if we are talking about kubeadm, this is stored on the host below the directory etcd. So all the data is in here. Okay. First of all, we create again a secret. Create secret generic my secret. So this is a new cluster, so I have to recreate it again. Password, and again, greatest password you can imagine. And the secret exists. Great. So now let's try to get this information directly from etcd. So we do etcd control get registry. So etcd is a key value store, so you can navigate through the path. This is the default namespace, and it's called my secret. And it doesn't work. Why it doesn't work? Oh, let me type. Yeah, okay. You see, the password is stored in plain text in the database. So let's change this. We have to teach the encryption config to the API server. It's basically the encryption config you have seen in the slides. So we are making the secrets encrypted. So we copy the encryption config, and I'm probably again in the wrong folder. Tasks. We copy the encryption config into this magic folder, which is already mounted to the API server pod, which is below root API server. And then we have to configure the API server. So we vi Kubernetes manifests kube API server. And I think I do some copy paste, otherwise I can get in trouble. So now we teach the API server this encryption config. It's basically the file which we copied into the pod. So we changed the pod manifest in the static pod manifest folder, which means the kubelet now will restart this pod manifest, which means Kubernetes is not reachable anymore. That's fine. So it will take about 30 seconds. We can also take a look at the containers. So this one. And we simply have to wait. And hopefully it can start again. Otherwise I have a problem. Yeah, here it is again. So 3 seconds ago. So the API server started. So now I can talk to Kubernetes again. Okay, cool. And we taught Kubernetes now that it should encrypt secrets. So let's check our secrets. And this will not work, by the way. So we check our secret if it is encrypted, and it is not. And this is okay, because only new created secrets now will be encrypted, not the old ones. So let's try this out. Create secret, my secret two, generic. Password equals password 456. So the second secret is migrated, and let's take a look at the CD if this one is encrypted. And for me, this looks encrypted. Okay, but what is with the first secret? So we can do some hackish thing here. We simply recreate all the secrets we had created before. So we get all the secrets from all namespaces and replace it, basically. And that's it. And now if we take a look at the first secret, it should be also encrypted. And for me, this looks encrypted. Cool. So now all the secrets are encrypted in the database. But there may be dragons. It's not that simple, especially if we talk about backups. So let's try out something. So for sure, you should put backups in your of your etcd database. So let's create a backup. Snapshot save backup db. And check if there is some password in plain text. So we check for, let's check the second one first. It's not in there. Is the first one in there? Yes, it is. Although we already encrypted the secret. And the reason for this is that etcd has some copy on write mechanism, which means that the old revision, the unencrypted revision, is still in the database. And so if you do a backup, also the plain text password will be in the backup. How to change this? And now it gets tricky, and hopefully this works out because I had some troubles also here. So first of all, I want to take a look at the snapshot. And here I see the revision number. And I want to do a compaction of the database, which means that the old revisions which are not needed anymore get deleted in the end. So we do etcd control compact. Oh, this was nonsense. This is the proper version. So now we compacted the database. Now the question is the plain text password still in a new backup? So let's create a new backup. Let's go to backup 2 and take a look if it's still in there. And it is still in there, which is very interesting. The reason for this is that the compaction doesn't run immediately, so there's some delay. This is how etcd works. But we can do something additionally here. So we can do some defragmentation. And now, hopefully, the plain text password is away. Oh. Snapshot backup 3. And now we do the cut again. If I find it, backup 3. Now it's gone. And that's really tricky in my opinion. So adding the encryption to your API server, this is rather straightforward. But keep in mind that in the database, the old plaintext passwords may still exist, and you have to do some etcd magic to get them out of the database. So a compaction and a defragmentation in the end. And also be aware that if it matters where you put your backups. Don't put them on some public places because this would be very dangerous. Okay, then back to the slides. Yeah, here on this slide, I wanted to show, this is how etcd works. So if you create a new version of an object, the old version still exists, and that's the reason why we need compaction and defragmentation, that it really gets deleted from the database. So yeah, we already did this. So now the database is also in green dots, which is not very visible on the slide, but now the database is also safe, or the backups are also safe. I already mentioned that you can avoid a lot of that stuff. Also, we are using some other tools. If you don't want to store your secret data, your sensible data into etcd, you can use, for example, HashiCorp Vault. And this is an admission plugin, which means you have to teach your API server that the HashiCorp Vault's sidecar injector should be added to your Kubernetes cluster. And what happens next is that on pods, if you apply pods into your Kubernetes cluster, sidecar container and the init container will be added to these pods and take care about the communication with the Vault server and inject the sensitive data into your pods or containers. And so in the end, the secrets are not stored anymore in etcd. You have to add some annotations if you go that way. So yeah, so this is annotation based. So yeah, this is also something which is some kind of a lot of annotations here. There's another way, the container storage interface. Let's talk about the container storage interface first, why this exists at all. In the good old times, Kubernetes delivered the container storage drivers, let's call them drivers, in tree, which means it was in the part of the Kubernetes project. This changed, I think, 2 years ago or something like this, where they tried to put all this storage stuff outside the Kubernetes project, and they again implemented an abstraction. So you have to implement an interface. And the reason for doing this is that the cloud providers like Google, AWS, or Azure can iterate on their container storage implementations on their own pace and do not rely on the Kubernetes pace of releases. And one of these CSI drivers is the secret store CSI driver. And it's basically doing exactly the same like the HashiCorp Vault injector from the functionalities point of view, which means it grabs the sensitive data from somewhere else. So you have to create such a secret provider class in your cluster. In this case, the provider is GCP. And inside your pods, you don't have to add annotations. You can add the link to the secret provider class in the volume section. And yeah, you add the my provider in the secret provider class. A few words about the secret store CSI driver. It's still in alpha phase. So yeah, not that stable yet. And it supports currently backends for AWS, Azure, GCP, and Vault. So Vault again. And it's the same idea. Don't store the secrets in etcd, store it somewhere else. So this is also something which you may can consider if you have concerns about the secrets in etcd. But now, King Admin, after being attacked multiple times, starts to become proactive. And he wants to actively prevent strange things happening in his cluster. And the first thing he's doing is checking the craftsman. So he is basically doing static pod analysis and image scanning. First, let's talk about static pod analysis. So this is Kubernetes again, and now Hakarios has access to the API server and wants to create harmful pods in the end. And with static pod analysis, we can prevent this. Let's take a look at the labs. One of the tools which are very nice here is kubesec. And it's very straightforward. So you only have to install it basically, and then you can do kubesec scan, and let's scan our pod. And what you will get back is a JSON structure. In general, our pod is valid. Yeah, that's true. But we get the negative score. And this means from the securities point of view, not so good. And there's the critical section and there's the advice section. And you see the critical section minus 30 points. So let's care about the critical things first. So let's change our pod. And I think this was about privileged and allow privilege escalation. And we don't have to apply it now. We can simply scan it again. And now we have a score of 0, which is better than before, but still not great. Now we have no critical stuff in here, inside here anymore. So we have advices. Yeah, we have no resource requests and limits. We have also capability stuff in here. And we run as root. So let's change a few things here again. So now we stop running as root. And this will also be true. And we add the resource requests and limits, which is a good idea, not only for the scheduler, because he would like to have this information for doing smart decisions, also from the security point of view. So, scan again. And now we have a score of 6, so we are already positive. And there are still some advices. Yeah, I think you get the idea. You can do static pod analysis very easily with kubesec. And if you want to go on pro level, then you do that in your CI/CD pipeline. So if you have some GitOps in place, so Argo or Flux, you could integrate this into your CI/CD pipeline. So before something gets deployed to your production Kubernetes cluster, it has to pass kubesec. And you can even go further. You can add kubesec to your production cluster. And yeah, this, for example, cron job checks the running pods about their security risks. If this is okay from the resource perspectives in your cluster. Next topic, image scanning. The supply chain security is a big topic nowadays. So image scanning checks the container images if there are any vulnerabilities. And yeah, directly to the labs. In the labs, I want to show you how this can work with Drivey. Drivey is a very nice tool from Aquasec. And again, we do this in the terminal. It's already installed, and now we can do image scan via Drivey image. For example, let's take the latest Nginx. First things which happens here is the database gets updated because new vulnerabilities. And we see a lot of things here which is going on with Nginx. So yeah, maybe we should check this. And if you are only interested in the critical stuff, you can do this. And now we get only a list of the critical stuff. And so now you could care about these vulnerabilities. If you want to shrink down the security risk, it's a very wise decision if you use small container images. If you go extreme with distroless, yeah, can be a little bit of difficult on debugging stuff because there's no bash in there, but Let's try, for example, an Alpine image. Image severity critical, and let's go with the latest Alpine. And there are no critical vulnerabilities found, which is cool. So let's try out this private tool. I want to know if a specific version of KVM-based product gets a critical alert about log4shell vulnerability, which means that Strivey also checks the dependencies of your applications, which is very nice because Elasticsearch is depending on log4j, and in this specific version, there is the log4shell issue still in here, and here it is. So Strivey tells us this also from dependencies of the applications which are running. To be fair, let's try a later version, and for sure, Elasticsearch fixed that stuff. But it's a huge image, so it takes a little bit longer. Interestingly, the Strivey doesn't use the image cache here, so it does a download of the image each time you run it. And that's the reason why it's taking so long. Yeah, so a new version of Elasticsearch also looks good from this point of view. Okay, cool. So, pro tip, do image scanning, also in your CI/CD pipeline. And you can imagine what happens next. If you do it in your prod environment, this is also something nice. But for sure, you need some compute resources for doing all that stuff. It depends on your context. So now we have a gate. Before stuff gets deployed to our Kubernetes cluster, static pod analysis and image scanning is happening. Cool. Next chapter. Now even the gods come into play, and the god Kyverno backs King Admin. You can restrict what gets deployed into your Kubernetes cluster with Kyverno. Before talking about Kyverno, we should talk about the API server a little bit more in detail. So we already have talked about this yesterday. So somebody who is using Kubernetes is sending some pod manifest, or maybe some application is doing that to the API server. Then authentication and authorization happens. We already talked about this yesterday. And then there is admission control. And if admission control is fine, the object we send to the API server gets stored into the etcd database. And we can customize the admission control via mutating webhooks and validating webhooks, which means each thing which gets sent to Kubernetes can be mutated or validated. This is, by the way, exactly the thing what Istio is doing. Also the Vault secret mechanism is doing. So they are mutating the incoming pod manifest. After mutation, validation has to be done, and you can also create validation webhooks. Something about pod security policy. Some of you may know pod security policies. In the past, we used them, and they did a pretty good job, in my opinion, for avoiding stuff in your cluster, evil stuff in the cluster. But with the next Kubernetes release, they will be removed. So pod security policies are no option anymore. So we have to find something new. And there are two big ideas how we can achieve this situation. This is how pod security worked. This is OPA. So the first one is OPA, and OPA is already existed before Kubernetes, I think at least. It has a broader scope. It's not only built for Kubernetes. You can do a lot of stuff with OPA, and that's also the reason why OPA has a specific language. So if you're using OPA, you have to learn Rego. This is the language where you can basically say each pod which gets sent to the API server has to be the container of the image of the container has to be from this registry in this case. And if not, send out this error message. Yeah, there's a second way of doing that stuff, and we will use this in the labs, which is called Kyverno. Technically, it's very similar, but it has, in my opinion, the nice thing that you don't have to learn a new language because Kyverno is Kubernetes native, and you have to write YAML. What else? And this can look like this. You write the cluster policy, and one flag is the validation failure action, which means if the condition is true, then send an error message. This is done via enforce. There's also a second way of configuring this. This is audit, which means there's no error message, it only will get audited. And we are basically saying the same as in the Rego language. We are saying this is true for all pods, and if the image for a container in this pod is not coming from this very specific registry, don't allow to deploy it into the Kubernetes cluster. So let's try this. On our cluster, Kyverno is also installed via Helm chart, and we have a separate namespace for Kyverno. So I have to open my cheat sheet, and now I will apply the image, the cluster policy as we have seen in the slides, which basically means that all the images have to come from a very specific registry. And this one is called image whatever policy. First of all, we have to delete the bot because we have to apply it again. Part and now apply it again. Pods.yaml, and I would expect an error message now because we are not using this very specific image registry. Yeah, and this is what happens. So in the API server, this validating webhook, we're basically saying, no, this is not working. So this is also, in my opinion, very straightforward, and you can do a lot of more stuff. You can restrict a lot of stuff in your Kubernetes cluster with Kyverno. This is a very simple example. Now I have to delete the cluster policy again, otherwise I can't do anything with the cluster again. So cluster policy is deleted, and now I should be able to apply the pod again. Okay, cool. So what did we do? We added a security gate in the API server, and you can be very creative with Kyverno rules here. Cool. Now the kernel goes also back King admin. Now we are trying to make some security stuff with the on host level basically. There are products like AppArmor, but also SecComp would be also possible to use here, which are Linux security modules. So this is running on host level. This is not deployed via Helm or cron job or something like this. This is deployed on the host. And we can blacklist and whitelist stuff we want to prevent or allow. We have to create some AppArmor profiles. And in this case, we are basically saying nobody is allowed to write in the end anything. So here we are talking about writing files, and we are avoiding this with an AppArmor profile. How to engage this in a pod? Again, we have to use annotations here. So yeah, here we are saying use for my Ubuntu. This is a container in the pod. This AppArmor profile, which is located on the host. So let's try this. And first, before we do this, I want to check if I can write stuff in my pod. So let's do a kubectl exec, my suboptimal pod. Touch temp some file. And this looks good. Let's check it if it really worked. And yeah, some file is in the pod. Great. So now avoid such operations. So first of all, we have to check if AppArmor is installed. And yeah, it's running as a Linux service, so this looks good. There's also another way to check this. There's AppArmor, a specific file where you can enable AppArmor. And yes, it's enabled. Great. And if you want to check those profiles, there's a command which is called AA status. And you get the list of enabled profiles in your AppArmor installation. To add a new profile, and this is exactly what we do in the next steps, we have to copy our profile to a specific folder. So let's check this folder. etc AppArmor D. And yeah, there's already stuff in there. This is vanilla AppArmor installation, nothing added from my side. This is how it gets delivered. So the AppArmor profile, which you saw on the slides, is also located on this machine. So let's copy it into this folder. So we copy this one. I think it's my AppArmor profile. Yeah. Into etc AppArmor D, and we have to restart AppArmor. AppArmor. So now the profile should be enabled in AppArmor. Let's check this. And here it is. So AppArmor now knows our profile. Let's see if it does its job. Before doing that, we have to add the annotation to our pod. So we do vi pod.yaml, and I already prepared the annotation here. So we are basically saying on the container my Ubuntu, which is the name of the container you see here, please engage the my AppArmor profile. So let's do this, and I have to apply it, the pod first. And I have to force it in this case. And it's running. So now try to write again. Touch temp some other file. And we get a permission denied, which is exactly what we wanted to see. Cool. Fine. I think we can leave it as it is here. So what we did here is we added to the worker node this AppArmor on a Linux service on host level. which allows us to prevent stuff to be done in the containers. And again, you can do a lot of other stuff with app armor than preventing writing files. Now some history lesson again. Maybe some of you already know that. The reason why we are talking about log files is very interesting. And also in the times back when King Admin was living, they had ships, and back then there was no Google Maps, so they had to do navigation via writing down in which direction they wrote, in which speed, basically. So they needed to know the speed of the boats, and so they had a great idea. They had a rope, they had a log, and they did some knots into the rope and bound the log on the rope. And so they could find out how fast the boats are, because the question was how many knots pass their hands when they throw the log into the water. And that's the reason why we are still talking about logbooks and logs. And also, King Admin did know that, and so he has a great idea. He wants to have more log information. And the first thing he is using here is built-in Kubernetes auditing. So you don't have to install anything, you only have to engage it, basically. You have to create the audit policy. And in this audit policy, you're basically saying, please give me information each time somebody get lists or watch a secret in the default namespace in this case. And that's basically it. You only have to teach it to the API server afterwards, and this is basically it then. You see here also some stages and also the levels. Let's talk about those two fields. A stage defines when this logging event should happen. When the request was received, or when the response was started, or when the response was complete, or if a panic occurred. So this you can define when such log messages should happen. And the levels allow you to influence the information you log. None, log nothing. Metadata, only logging the metadata, and request response. I think they are very self-explaining. And for sure, we have to teach it to the API server. We will do this in the labs. Okay, where are the labs? Here. It's again exactly the example from the slides. So we want to know if somebody get lists or watch the secrets. So we copy again the audit policy into this directory, which is mounted already in the API server pod. And then we have to tell the API server, hey, there is this file, please consider it. So let's do that. We again use the static pod manifest here. Cube API server. And now I do some copy paste, otherwise I do a lot of typos. And in this line, we are basically saying, please consider this audit policy configuration file. In this line, we are saying, log to this file. This file, it has to be in the API server. So we place this also in the API server directory. Then you can define how old the log files are allowed to be. I think we are talking about days. So everything which is older than 10 days will get deleted. And you can also define the maximum size of such log files. I'm not sure which unit this is, to be honest. And this is important, to be honest, because if you really log everything, this file will get huge. So you can't log everything which is going on in Kubernetes. You have to make your choices, or you have to have a very big disk. Okay, we configured our API server, so now Kubernetes isn't working anymore. And again, we have to wait until the pod is up and running again. So let's wait a few seconds. Okay. Now it's up again. Now we can talk to Kubernetes again. So we engaged Kubernetes auditing for secrets in the default namespace for get, list, and watch. So let's try if this is working. First of all, check the log file. So default log. The file exists, but nothing is written in there. That's fine. Now let's get the secret. Secret. And now we have an entry. So each time somebody grabs a secret, we have an entry in our log file. And for sure, you should have this log file, this log file, not only on this worker node or on this master node. You should send this to some Elasticsearch or Loki database for centralized logging. Okay, cool. Then, so we have now here audit logs. So we know now what is going on in our Kubernetes cluster. And every time somebody is getting some secret, we will have a logline in our log files. King Admin is still not satisfied, and he even wants to go further. So he is using Falco. And Falco is a threat detection tool for Kubernetes. And it's very straightforward. So yeah, you have to, so Falco is installed on host level, and you have to configure it. There are some rules files, and typically the rules files which get delivered with Falco are very good. So there are already very good defaults in there. But for sure, you can write your own rules too. And yeah, this is what will be doing in the labs. We will configure again the path where the log file is located. And if you want to write a specific rule, this can look like this. I will not go into detail here, but there's some condition, there's some output, and you can use some variables, because Falco provides also a lot of nice fields which are very useful. So let's try this. First of all, check if Falco is running. It's running, and we already have some error messages in here, which is fine because Falco was running all the time and is already configured properly. So let's do some extra computation for our Falco installation. In this config file, you see the rules file section where you can add your rules files if you want to. We are fine with the existing ones. And somewhere there is the file output section, hopefully somewhere. Here it is. So we enable file output, and we want to log that stuff into, we are on host level now, so we can log it to Falco.log. Restart the service. And let's check the log file again, this log file. Log Falco. It doesn't exist yet, and that's fine because no event happened yet. So let's provoke an event. Let's do a bash call into the optimal board, and now we are in the container. Exit again, and we cut the log file again. It should exist. And we have a log line that somebody created a bash process in this container. So now we have, and this is a default rule from Falco, so we didn't have to configure anything here. So this is how Falco was delivered. And this is already very nice to have this in place. Okay. Okay, we have the Falco logs in place. And the last thing I want to show you with a live demo is benchmarking. Maybe this would be, it would make sense to make this the first step in your journey to do a benchmark about your Kubernetes cluster, what is fine and what is not fine. In this case, I will use kubebench, again from Aqua Security. So let's do this. I have to take a look because otherwise we are running a little bit out of time. Where is it? Okay. I will deploy kubebench as a job in the Kubernetes cluster, and I will simply do this. And that's basically it. The container is creating, and it's already completed. Take a look at the logs. Kubebench. And what kubebench does, it checks a lot of stuff, all the configuration of the control plane components, but the API server, and you see I have still fails and warnings. So this is a very good starting point in my opinion. So maybe to start with all that stuff, take a look how your cluster is doing at this point in time. And so via kubebench, which you can simply deploy with a job, you get all the information, what is maybe all wrong with your Kubernetes cluster, and what is also good with your Kubernetes cluster. Okay, last thing, we have kubebench here. So King admin is now happy again. Some honorable mentions. Yeah, use small images, distro-less images. Make your containers read-only. There's one flag in the pod specification. It's called read-only root file system, which is also a very nice thing. Image policy webhooks. If you use Kubernetes, you don't need them, in my opinion. Network policies. Those are small firewalls within your Kubernetes cluster. And container sandboxing. I haven't covered this. You can use gvisor or Kata containers, which you can use instead of run C. And then you have, it feels from the encapsulations point of view, it's more like a VM and not like a container. Don't be this guy, because this guy will be back. It's, by the way, a phrase from some great Austrian actor. Questions?
Yeah.
Are there any questions?
There are some questions. I hope we still have.
Chrissy, I think you're muted.
Can you hear me now?
Yeah.
Yeah. Okay, perfect. There are some questions. Let's start with the last one. Can Falco and Apamor also be used in cloud environments where you don't have access to the nodes, like GKE Autopilot?
I don't think so, because you don't have access. I think to the worker nodes in GKE you have access, so you could use this for the worker nodes, but for the every time you have to configure the API server, this will not work out because you can't touch the API server in GKE. But to be honest, Armor is coming from Google, so maybe check on the worker nodes. Maybe it's enabled by default.
Next one. So where can we learn the security topics? Do you recommend any book?
Yeah, there is Kubernetes security, I think it's simply called. This is a rather new book, I think, from O'Reilly, but I haven't read it, to be honest. I can recommend the stuff from Code Cloud. There's a lot of nice things, so labs where you can play around. Or you can, yeah, I'm doing this webinar on conferences as a workshop, so where you can do all the stuff I showed you today on your own. This is also something we could do. And hopefully sooner or later we make all the stuff I did available to the outside world also. So there's also some discussions at Kubernetes if we can provide some lab environments to play around with all that stuff. So my first tip would be maybe Code Cloud, because they do really great stuff.
Then we have one more technical question. How does kubesec compare to kubepanda by Aquasec?
To be honest, I do not know. I do not know kubepanda. I do not know this tool. So I can't give a good answer here.
I think that is completely fine that you cannot know everything. Will there be a follow-up webinar with the more advanced in-depth security details? I can start to answer that. We have nothing planned for the moment being. I pasted a link to the next webinar we are going to have, but we can see that there's a lot of interest in the security topic, and therefore might think about more security topics in the future. I don't know, Hubert, if you want to add something to that.
If there's a demand for it, I think we can think about it to go even more in technical detail in specific topics, because this was more a kind of overview. And for specific tools, for example, look in detail into Kubernetes or look in detail in OP. This would be a nice webinar topic. Maybe you can send us your specific tech topic which you are interested in, and then we can discuss if this makes sense.
Yeah, of course. Like, we only have 1 minute left. I see a couple of more questions. Potentially you can send them to us via email. Hubert's email address is hubert@kubernetes.com. Also, if you have suggestions for like webinars that we could do in the futures, we are always open to that. So please feel free to reach out to us. And then I want to like use the very last minute for like some promotion in our for some promotion. So I already told you the next webinar will take place on the 23rd of August, and it will be about pimp your Kubernetes cluster with Cilium, ABPF-based networking and observability. This will be a joint webinar together with Isovalent, the creator of Cilium. So please register if you're interested in that. And then the next slide. We do have Container Days coming up on the 5th to 7th of September. It's a hybrid conference. It's a super nice on-site conference with really a festival-like atmosphere. I've been there a couple of times, and I really, really enjoy it a lot because it's a real community conference and very laid back. The online tickets, of course, are for free. If you want to join us on site, then again, ping Hubert, because then you can get 50% of the standard ticket price. A lot of use cases to reach out to Hubert, either with questions or suggestions for future webinars. We both thank you very much again for joining. The recording will be sent to you in the coming days because we had the question as well. And I wish you a nice rest of the day and hope to see you soon. Bye.
See you. Bye.